Hello, everybody, and thank you for taking the time out to come and see us. So this webinar is called Effective Requirements, or Why the User Stories and Use Cases Are Not Enough. I'm sure you've all heard of Feabhas from the past. So we're a world-class embedded training company and consultancy, and this area comes from a lot of work we do regarding sort of the requirements analysis area. So the objective of the webinar really is to initially give a very brief background on use cases and user stories and to put those in context, and then look at some of the major weaknesses or issues associated with them today, and look at where they affect the requirements model, and then take a step back and look at requirements. Now, obviously, there's a very limited time here. Requirements is a massive area. So there's only so much, but this is really in the focus around what are they trying to do, and introduce the idea of models and where models fit and how we need different models and requirements, and then finish off looking at the concept of what is called an ends mean hierarchy within the requirements model itself. So Frederick Brooks, in his very famous essay, No Silver Bullet, said the hardest part of building a software system is deciding precisely what to build. No other part of the concept is as difficult as establishing the detailed technical requirements. No other part of the work so cripples the resulting system if done wrong. No other part is as difficult to rectify later. So I think most companies are aware that the requirements, of course, are such a major influence and such a difficult thing, and we're still struggling many years on to really try and get this requirements model right. So briefly looking at use cases and user stories. So use cases themselves, so Jakobson originally developed them, Arvid Jakobson developed them. It was down some work he was doing in the late 80s in his PhD. He published his own methodology in the early 90s called OOSE, Object-Oriented Software Engineering. And that was what really brought use cases to the sort of mainstream as such. But the real difference was when they were incorporated in UML, as UML evolved from the unified language into the unified modeling language. And that's where they became almost de facto mechanism at the very early stages of software modeling as such. If you look at the current UML standard, then they describe use cases. It says use cases, the behavior of use cases can be described by a set of behaviors such as interactions, activities, and state machines, or by preconditions and postconditions, as well as natural text where appropriate. Now, I'll come back to that a little bit later because obviously that's got a very broad meaning with it. A lot of people focus on the diagram, but actually from a use case perspective, it's what's behind the diagram, is what makes use cases work or fail within them. Separate to that is user stories. So user stories have come out of the Agile environment, so the extreme programming that's into the sort of late 90s, very much the early 2000s when we saw the Agile agenda coming along. And this was quite a different change, and it's a much higher level model. And they've been around for a time, but it really Mike Cohen's book that brought, again, user stories to a more accepted area, and they've certainly become incredibly popular. And within the book, he describes a user story as each user story represents a discrete piece of functionality that is something a user would like to do in a single setting. And as part of that, there's been this adoption of this sort of pseudo-standard model for writing use cases. A lot of them work using a physical card. This links in with some of the Agile techniques such as Scrum and Lean, where people are using Kanban boards to do workflow management. So the idea is that there's this high-level card, and on that card, it has a very simple structure where you capture, as a user, I want to achieve some sort of goal so that there is some sort of benefit. So very easy, clear model. The second part of the C is the idea, of course, as a story, it's capturing some sort of conversation between the user. Now, what they're doing in the Agile world is, rather than doing generic users, they're trying to create the idea of personas. They use a persona-based model to sort of talk about how do we sort of envisage this system working. But also what's quite nice about user stories is the third C, which is this confirmation. So there's a lot of early emphasis on trying to say, well, how are we going to demonstrate this? How are we going to show we're done? So based on this idea, this feature we want to achieve, what is it going to look like? How are we going to see that? So quite different from the use case model. So the first mistake, I think, or the first thing we're seeing with use cases is the way they're being used, the way people try and use them. So use cases, the background to them, their original intent was really they're about specifications. So they weren't ever intended to be quite part of the requirements capture model. They're much more the requirements analysis model. And we've always seen them as the bridge from the requirements to the actual architectural design. So they're a technique, if used in their original intent, to try and look at, especially the system design as it stands, and from that help formulate the underlying software requirements and then lead it through into that design. So they're very much assuming that a requirement exists. Now people change that, and over the years people have reused that, but that was their original intent. So if you look at where they came from, like I say, they weren't about requirements capture. However, user stories were. That's really what separates them, is the intent of user stories, and from an Agile perspective was this, as they call it, this rally against requirements. Looking historically and saying, well, the requirements and the way we've been doing requirements has failed for decades. We never get good requirements. So why spend all this sort of time? And if we can use this model where we use the user story as a unit of work, we can then build this workflow model based around things like Lean and Scrum. So the typical technical Kanban board, and that allows you to track the work going through with it. So many Agilists believe that there is no need for a requirements document. Now again, we realise that isn't that in reality for many systems, but that's where they come from. And certainly in certain systems, that is the way it's being done. That is purely this board-driven, Kanban-driven model where the user story represents the unit of work as such associated with it. So firstly, they're very, very different. You know, user stories are centric to, they are about the requirements capture area where use cases weren't originally meant to be, but they can be used in that way. So where are the issues? And the first big issue is neither are systematic. So when you say, well, what makes a good use case, or what makes a good user story? And if you get 10 consultants in a room, you'll probably get 10 different answers to do with that. And again, if we look at the spec, you know, we look at the UML spec and we look at the text related to it, you can see that text says, well, I can do this, I can do behaviors, I can do interactions, I can do state models, I can do text. It's like, well, I can do whatever I want, really. So that's very flexible, but of course means how do I, if two people use use cases, they may use them completely differently. And typically we find a lot of people are not using them effectively from that. People have done work around trying to make them systematic. We've done a lot of work around systematic. I'll mention at the end that there's a series of blog articles where is the way we've used them over the years to try and give a framework that allow people to use them. But as they stand in UML, there's a lot of interpretation within that. And to an extent, the same applies to user stories. If you read this user story stuff, it's deliberately very vague. You know, the books say you shouldn't trouble yourself too much with the exact structure of a user story. So it's fine in certain things, and you look at different types of problems, saying, well, if the problem is not well defined, then we need the abstraction of the user story. But at some point, we've got to. That's not enough. That's a massive risk with the system. The other thing they suffer from is sprawl. Both are challenging to deal with the fact that when you look at any sort of true system requirements, there is a hierarchical nature there. A lot of people have abused the use cases over the years. And the diagram, right, the classic diagram we've seen many times, where people are sort of misusing the include notation for decomposition. That's not what it was ever about, for those that know use cases with that. And I understand why people do it, because they're trying to solve this hierarchical nature of sub-functions within functions and sub-needs within these, but it breaks the whole use case model, and again, doesn't really, it's not the intent and not what they're meant for, and they become very sprawling, and they just don't work very, very well. Now, Alistair Coburn did some very good work. His book about use cases was probably the first book that tried to give some systematic view of use cases, but even he struggled with the hierarchical nature of use cases, the fact that we can have quite high level use cases, but quite detailed use cases. And that's never been very well resolved. With the user story model, the approach they take there is this, they sometimes use this concept called epics. So when a story is too large, it's sometimes referred to as an epic. Epics can be split into more stories. But again, that's really all they say. The general idea of an epic is, from an Agile perspective, it's bigger than is deliverable in iteration. So the whole point of stories is, if you're using something like Scrum and you've got a 2-week iteration, that a story is something that can be delivered within that 2-week time frame, where an epic is something that can't. It's bigger than that, so you'd split your epic into multiple user stories. So there is a hierarchy there, but again, there's no systematic model to it. So the way people use epics, the way that people use stories varies massively from organization to organization. Especially in the embedded space, in the real-time embedded space, we have to live in the real world, and unfortunately, we are standards dictators. Now, what's been interesting, because use cases have been around for almost 30 years now, in a sense, fairly accepted, certainly for 20 odd years. We're seeing some standards coming through that are referencing use cases. So a couple of examples here is the SOTIF one. That's actually a standard to do with the safety of the intended functionality. It's an automotive standard, the 2144. And in there, they actually, from a requirements perspective, they do talk about use cases. Now, they've actually slightly adapted it, and it's an interesting one where they introduce additional behavior on it, this concept called scenes as well. But they're trying to use cases there very much as a requirements capture mechanism. The lower document is actually the FAA, the Federal Aviation Authority, Department of Transport, FAA. And that's actually, it's a very good document. It's called the Requirements Engineering Management Handbook. And again, in there, they are trying to use cases for requirements definition and requirements capture within that to the degree of success at certain areas. And we'll come back to that a little bit later. So standards are driving. Some standards are trying to address this model through use cases. Now, in the user story, back to Cohen's book, and he wrote this phrase in the book saying, documenting a systems requirement to this level, and he was referencing IEEE 803. IEEE 803 is the IEEE recommended practice for software requirement specification. Is tedious, error-prone, very time-consuming. Additional requirements document written this way is quite frankly boring to read. I don't disagree with him, but it doesn't mean we shouldn't use them. It doesn't mean we're not, we have compliance-based quality. There are times we have to do these things. It's not that we want to do them, we just have to do them. So to dismiss them and saying, well, we need a better way, I'm not disagreeing, but we don't always have that control over it. So we have to make sure that if there are standards we're working to, then the techniques we're using can be traceable and map into that standard, that requirements model as well. The other problem we see is that neither are addressing any concept of non-functional requirement. Now, people again have done different things. That there's a lovely concept called misuse cases. People are trying to address this. This has come out of the security world, where you have the crook or the baddie in there, which is good. It's quite a nice take on it, but again, it's sort of adapting and repurposing use cases from their original intent. And of course, from a non-functional perspective, there's so many other quality attributes that from a systems perspective, we just have to address, and they won't ever address, and they can't within the context of what they're doing, not without really getting very, very complicated models. Again, from a user story perspective, people have looked at it, and I've seen people present saying, well, yes, you can do non-functional requirements using user stories. And this was one example I pulled out that somebody had put forward. As a user, I want driving directions to be at best 90% of the time and reasonable 99% of the time. I think anybody with a requirements background would really question best and reasonable anyway, because it's like, that's a subjective measure, and that's not a story. Now, some of the Agile people are saying, well, user stories really aren't about stories, and it's like, okay, I'm confused now because it has story in the world. But so there is people trying to adapt user stories to address the things it doesn't address, and that's really just abusing them to an extent. Also, because they're both, to an extent, whether it's user stories or use cases, they're both looking at scenarios. They're different techniques in terms of when you use them and how you use them, but they're both scenario centric, and they are both very guilty, and it happens very often, of people putting too much user interface detail in the scenario, and not having a clear separation of concerns between any sort of user interaction or system interaction from the actual requirement itself. And this is very commonly written. You see people write use cases and they'll put detail, press his button, etc., his audible on. It's like, that's not the intent. That's, you're now driving system design already, which they shouldn't be doing at the requirement stage from that. However, my biggest issue with probably both of them is they fundamentally assume a software-only problem. So they really ignore systems. So neither have come from a systems background. So the boundaries to the problem are expected to be a user interface, people working with the system, pressing buttons, or even it may be network messages, but all of that is taken care of. You just have a message coming into the system, and we don't have to worry about this horrible thing called hardware that slows us down. So the very things like websites, usability, apps type thing. So both of them, and especially this is very true of the user story model, almost assume that's the environment you're working in. That's the sort of thing you're working to. Where certainly in the embedded space and the real-time space, at the minimum case, we tend to be software in a system. And of course, we can have systems of systems of systems, etc. It's very rare just to be a software system. And we've got to deal with physical hardware. Some of its systems may have almost no user interaction at all. It's a black box within, our engine management system, is indirectly controlled obviously by the driver, but there's no direct control within there. So we need mechanisms where we understand the different boundaries, the boundaries of the environment, our problem domain, the boundaries of the system, and the boundaries of the software. And any requirements must address those three separate things. We must make sure we're dealing with those things in that. So based on that concept, if we step back a little bit, so I'll reference the third book later, but Kovitz has this fantastic book about requirements, and he has this very nice model at the high level. And he talks about this idea of when we're looking at requirements, first is we've got to bound the problem. So we talk about the problem domain, and within the problem domain, there are people, there are things, there are abstractions, events, logs, etc. And there are things that need to be done, whether we call them functions, whether we call them goals, whatever. But that's our bounded problem, and that's really the core part of what our requirements is trying to capture is those things. And what we're moving towards ultimately is this idea of the solution domain. That's what we're building. So the solution domain is our platform, it's our hardware, it's our mechanical, it's our electromechanical system, obviously maybe fluid stuff, fluid hydraulics, etc. But ultimately, from a software engineer's perspective, we're dealing with the core processor, we're talking with the core hardware, the memory system, etc., and our interaction with the outside world from that. So that's our deliverable. That's what we're delivering. And really what Kovitz, he talks about this, and this I think is a really nice way of looking at it, is saying, what are we trying to do? So we're trying to configure the solution, our solution, which is ultimately a model, to bring about these certain effects, so with these goals or these functions or these features in the problem domain. So we talk about the problem domain and the solution domain associated with this. And we have this overlap, and this overlap is where how does our solution see the problem in that? And if you look at both, whether it's user stories or use cases, when we're dealing with requirements dealing with the scenario models in the requirements, it's very much that boundary. And that's a massive part of the requirements document. It's a significant part. So, I'm not saying that the use case and user stories are not central to requirements, but they are just one part of it. Now, you could argue that obviously from a user story perspective, it is dipping into that problem domain with some of if it's goal centric, and you can do the same with use cases. You need to raise alarms, report gas levels, those things that need to be done. But fundamentally, that's their focus, is around that particular boundary and capturing that boundary. So it captures one set of requirements, but it misses a whole load. So first off, we have, when we look at the problem domain, then we have this the core problem domain requirements, and that's fundamentally what our customer wants to achieve. That's their goals as such associated with it. And there are going to be primary requirements, and from that there will still be derived requirements within that as well. But also when we're dealing with, especially, like I say, real-time and embedded, then we have these problem domain constraints. Okay, and as the key here is, as we always say, these are things that are true whether we like it or not. The real world. And I've worked on projects where literally having to explain to some of the marketeers saying, we have limitations like the speed of light. We cannot go faster than that. I know you'd like it, but that's a limitation on what we're doing within that. And they're of course so important. And use cases and use stories tend to miss those as a central part of the requirements document. So let's put that in context. So Leveson has it. Nancy Leveson, if you're not familiar with it, anything she puts out, I'd recommend reading. Brilliant, she's got a brilliant book called Safeware. But her latest work is called Engineering a Safer World, and she has this really nice model. It's actually called a STAMP model. So she says we look at control problem. In that control problem, at the bottom we've got this control process. So we've got process input, process outputs, and disturbances from the environment. Now, if it's a controlled system, we will be driving actuators, we will be reading sensors of different sorts into our system. So we have our hardware, this is our solution domain, the automated controller. In there we have our control algorithm, we're writing, our software we're doing, but also that has got a model sitting within it. So the software itself is a model of the control process, what it thinks is going on. And of course, when things go badly wrong is when the model we have of the control process and control process get unaligned for different reasons. If we have humans in the loop, then of course there will be controls coming in through whether it may be keyboard related stuff, graphical user interfaces affecting our control algorithm, and there are displays going out. But a part of that, of course, the human is a control system in their own right. They are obviously reacting and acting on what they see as the control process, and that's coming through the display. So in industrial control, they'll have displays that they're looking at, and they have their own models as well. So there are human models we have to address. That is to an effect, you can argue, is the part of the business process, the way people are part of the system. We must understand that as well. And we must make sure that our overall requirements is taking into account not just the solution domain in terms of what we're going to build, but aspects of the problem domain that include the human interaction and those things within that. And that's where, of course, procedures make a massive part of that. And this is where we look at from an embedded systems perspective, that we have this need for hierarchical requirements. So at the system level, when we're looking at that boundary level, we're going to be focusing on what the actuators are doing to the environment, what the sensors can read from the environment, and that's going to be in sort of information, rates, values, whether it's temperature, whether it's pressure. We've got to make sure we're capturing that sort of information associated with it. And the same goes to the human, from the human perspective. It's the purpose of what we're displaying, the purpose of the human controller interacting. What are they trying to achieve? So this is where our goal-centric model comes in. We're understanding and need to understand the goals of the system and the goals of the human controller as well. But when we look at it from a software perspective, of course, our boundary is saying, well, when we want to drive that actuator, we must make sure that there is a clear, from a requirements perspective, the traceability from what we want the actuator to do to how we're going to achieve that. So that may be a voltage that relates to some sort of movement, or from a sensor, it may represent a temperature range, which we're going to see through something like an ADC as some sort of, say, fixed point binary number with that. So key to that requirement is ensuring that traceability across those boundaries, the system boundary to the software boundary. And of course, the same goes from the human controls, that when somebody presses a button, how are we going to see that? Is it through simple GPIO? Is it interrupt driven, etc.? And from our display perspective, when we're driving displays, is it over an SPI burst, or is it a direct bitmap memory within those? So key to our requirements is traceability, and we've got to make sure we don't break those down. And a guy called Miller extended what was called the 4 variable model. So there's 4 variable model been around in the systems for quite a time, where we have our monitoring control. So this nicely captures this idea of those boundaries, in the fact that at the top level, at the system requirements level, we have this monitoring control relationship, and we must make sure from our requirements document we're clarifying those aspects within that, and there are certain assumptions being applied to that. That will lead to, for example, our input. So we're saying there, for example, we could be a temperature range, and that, so he talks about monitor, but in the software there is this the monitor tick model in there. And key to our requirements is ensuring that for every interaction between things in the problem domain and the solution domain, we're clear about that, and not just the values, but also the underlying protocol. So by protocol, I'm not talking about TCP/IP. I'm talking about any ordered sequence of actions. That is a protocol. And most commonly, one of the ways we want to represent that, we're talking about modal or stateful behavior. We must make sure we're capturing that as well. And again, that is a major weakness of something like use cases and user stories, is they don't deal with the modal nature of systems and the modal nature of interfaces in many ways within that. And same again, we can apply to the output model as well. So we're talking about models. So humans have models, our computer system is a model, the requirements is a model, the design is a model. So we've got different models, and all models are abstractions. So that's obviously the key of an abstraction is about filtering the amount of detail. And a good model will leave out unimportant details, but obviously that is then subjective within that. So we need different models, and this is where people start to get when they mix their requirements up, they don't understand that we have to deal with different models. So the first set of models, and models that most engineers are drawn to, is what we call the blueprint model, or the model for construction. And this is really where we've got something, and from that we can build it. Now, in a sense, code is this model. Code is a forward-looking, and from the code we generate the executable, we generate our target image. So we're drawn to this. This has to be very precise, very formal, and has a huge amount of detail to it. We can't have ambiguity here, because otherwise we can't build it within that. So we can think from manufacturing, but code to an extent from a software person is this model. It's forward-looking in a sense. And we use, there are models for this. People use things. So MATLAB as an example. MATLAB is a proprietary tool, very, very good tool. But when MATLAB is trying to do code generation, it's that model for blueprint. When people talk about auto code generation from possibly even UML, they're talking about it as a blueprint model. So you have to be precise in there, and that can cause a very, very busy model where there's a lot of detail and difficult to understand. The other models the next model we have is what's called a model for literature. And that's understanding the past. What have we built? We need ways. And people sometimes think the model for blueprint is the model for literature, and quite often that isn't. And typically that isn't the case within that. And people say, well, the code is the documentation. Well, actually, it's not. If anybody's had to work on that. So this model is very important for things like maintenance, for feature enhancements, for bug fixing. We've got to have views of our system and our software based on what have we built, what have we delivered within that. Okay, so it may be very similar to the blueprint model, and hopefully it is, but that we have to make sure we understand what the purpose of this model is. And I say the purpose of this is about transferring knowledge of the technical detail, the artifacts of what we've done. And it will have more than just the software. It's all the artifacts, all the deliverables, everything around that needs to be captured. Things like configuration information within that. Then we have another model, and it's called the model for language, the understanding the now. So the purpose of this model is very much to describe the current situation. And this model is about helping us say, where are we on our journey and where do we want to go next? The challenge of this model is the audience, the stakeholders. That the difficulty of this type of model is that we need to satisfy the engineers, because they have to build a system based on this. but we also have to satisfy the higher level stakeholders, the beneficiaries, the domain experts. And this is a difficult area because we need a model that conveys enough information that domain experts go, yep, I understand that and I'm happy and that's how it should work. But an engineer can also go, well, I'm happy enough that I can then evolve that into a blueprint model and take it forward. So there has to be a degree of flexibility here. There has to be, and this is where abstraction is absolutely key. And that's what any good engineer can do, is they understand that abstraction model. And this will also evolve. This, as we move through what we've done, this will add till it eventually will become blueprints in that sense. But it's important that too early we don't want necessarily too much detail too early, too much precision too early, because it is a barrier to making or helping make further decisions about alternative scenarios. So it's still about the decision of, are we on the right track and where are we going next, and are there alternatives? And then the final model is a model for decision making. And it deliberately is a very, very abstract model. And the aim here is to try and allow us to make decisions, the major decisions, before we commit. So the intent of this really is about evaluating alternatives, as opposed to the language is saying, this is where we are and where can we go from here. But this is really the major view at, and this is key to the early requirements phase, is that high level. And it's been shown that too much formality here is harmful, because this has to be fundamentally in the domain model. The domain experts have to understand this. The major stakeholders have to understand it. So it can be very, very informal, and it's almost I call it your technical marketing, that not an oxymoron, view of the world. That high level, and that fits in a lot with the way people talk about the user stories and the personas. It's that particular view. So we have a series of models, and during a design, those models evolve, and they may go through an evolution, but sometimes they have to go through transformation. We have to change the model, the way we do the model, the notation we're using, the language we're using. And that's very true of, say, from decision to language. That has to be a transformation within that, where the language to blueprint, depending, may go through transformations, but also may go through evolutions within that. And there can be feedback as we go. If we've got a system of systems, then there will be different languages based on the system abstraction we're at the moment. So the higher we are, the looser it can be. Think about things like network diagrams. A network diagram still is precise, but is capturing the essence. This is connected over the internet to this type of thing. And it's absolutely fine saying, does it convey where we are? Do we all understand it? We're not going to build a system from it, but we have the understanding to continue the journey as such. So these models, we have to accept that there has to be different techniques for each of these. And the danger is we try and use one technique for all of these. And that's a classic engineering mistake, is we try and use engineering style notation, the sort of notation we'd use at the blueprint level, to try and define the decision level. Now, it may be correct, but it's not helpful. It's not really helpful. It becomes a barrier to understanding within that. So to put this in context, to try and then spec this out a bit, and where do we fit in with all of this? This is actually some other work from Leveson, and this is extended in this concept called intent specification. And she's expanded that in her latest book, about engineering a safer world. And I came across this many, many years ago, and this really helped me sort of formulate those ideas and saying, why are we getting these barriers and everything else? So this is in the context of requirements. He's saying within any requirements, there is this hierarchy. And we can think of this hierarchy as the sort of the why, what, and the how of the sort of system level of the requirements within it. So our highest level, she calls the purpose, and saying the first thing we must be established in a requirements is, what is the purpose of this system? We must clearly get that problem domain and clarify why this is doing the job it's doing. Now, most people within a business go, well, it's obvious. You know, what's the purpose of that early, purpose of an early mobile phone? And actually, most people won't tell me its purpose. They'll tell me what it does. So they'll say, well, it gives me the ability to make and receive calls without being tethered to a telephone network. It's like, well, yes, but why is that a benefit? Why would I spend money on that? And that's the purpose. It's the why. So we all have them, pretty much everybody now, we have our mobile phones, our smartphones. And obviously from a phone call perspective, the benefit is that from a family perspective, I know people can contact me. From a business perspective, it gives me that. Do I really want that? Maybe not, but that's the way the world is today. So it's about, the benefits from the business with the mobile phone means I'm contactable wherever I am in the world, very, very easily, etc. Most embedded systems, when we look at them, tend to have a very clear purpose. That's part of when we look at many embedded systems, that's one of their characteristics. They tend to do one thing very well, but occasionally they do more than one thing. You look at the modern smartphone. Well, not only what does it do, but what are the benefits? I can read my emails, I can browse the web, I can listen to my music, I can play games. It certainly has all these things it can do. Why are each of these a benefit, and why would I spend money on it? I had to laugh slightly at Apple's announcement yesterday of this forward-facing camera that does slow-mo, and my brain's going, why would I want to do that? It certainly, maybe I'm an old curmudgeon, but it certainly said, I'm not sure why I would spend money on this, but I'm sure there are people who come up with reasons for that. If you want to be, and that's it's always the why. And actually, there is quite a nice book out there called Start with the Why, which is really a marketing book, but it does force you to always say why. And it links it with something called a value chain. If we want to be hard-nosed about it from a commercial environment, where your business has to make profit. Obviously, they're a non-profit business, so you've got things like government, etc. They have slightly different goals. But if we take any commercial business, you're saying, well, any time you're spending money or you're spending time, there should be a clear why. That is a benefit to business. And for all businesses, commercial business, it should be a combination of these three reasons. Either it's seen it's going to make the company more money, so we're going to increase profitability. It may be reducing costs, so saving the company money, or in a lot of cases, it's protecting money. It's a form of insurance. We must do it, otherwise we may be penalised, certainly where you have regularity bodies. So if we don't do this, we're liable to be sued in some way. There's a litigation model in there. And you can do that for everything. Why are you sitting on this webinar? Why, if you try to say, what of these do you believe it's going to do for you? And it's an interesting, so this is called a value chain, is trying to link back up saying, okay, when I do that, what's the benefit? Why is this useful to me? And that's, we all choose that model. So that's so key to any good requirements. And when I work with companies and we do the requirements, it's such a pushback on many requirements because they think this is obvious, but most of the time it isn't when you really push back. And actually very few people often understand it. The next level is in the Leveson intent specification called the principles. From principles is the what. So going back to the mobile phone, what does it do? Well, it allows me to make tethered, untethered calls, etc. So, and these are, from a requirements perspective, when people talk about features, the major features of the thing, what the marketers put on their data sheets with that. But really, these are better. Each of these, so we can, the way I've always addressed this, and a nice way of thinking about it, is if you look at the life cycle of a system, and saying that during this cycle, we've got manufacturing, we've got distribution, installation, normal operation, we might have in situ maintenance, in-field maintenance, we might have return to base maintenance, and we may have to address end of life. And each of those has to be addressed, and each of those have to be looked at in terms of what goals do we have to achieve, what features do we need from that. So simple things like installation may involve calibration. We want to make sure from requirements we're capturing that, and not just it has to be done, but who's doing it, what's the persona, what's the user associated with that. Are we going to try and do things like over-the-air updates? That's a massive challenge because that adds a whole degree of security implications of doing that. Even end of life, is there software in the system, especially when we start dealing with security, that must make sure it's been erased or removed before it's resold on eBay? There's so many classic cases of people buying equipment from eBay that has sensitive information still on it within these. So that's the next level. We look at each of these, and each of these generates a set of stories or a set of use cases, how we want to think about them, but each have a set of sub goals within that. And then finally, we've got the black box behavior. And the black box behavior is really what most of us in engineering think about when we think about those requirements. How's the system going to work? That's the area we're very comfortable with. We can talk concretely about this. And this is really where, when we look at those system boundaries, we can clearly say, this is how it's going to work. This is based on this sensor reading. We're going to drive this actuator. We're going to display this value. We can get down to that detailed, precise view. And this is where we do need precision of that system within that. So this is this concept of the end means hierarchy, that the black box, the how, is a means to the end. The end is the why, the purpose, the ultimate goals of the system. Why are they bringing benefit either to people or to systems in that commercial model? And there's a hierarchy here, and it's actually a hierarchy of goals. And it's a many-to-many hierarchy. It's not a decomposition. It's a many-to-many. Now, again, with a lot of embedded systems, because the why, the purpose, there can be what might on the surface appear a single purpose, but actually when you dig into it, there quite often are a couple of key purposes there, because there's different stakeholders and different domains we have to address within that. So using that model, that Leveson model, the intent specification, then we can overlay that with our different models, and realizing that for each of those levels, those abstraction levels in the requirements, we must apply different modeling views to them. We must, when we're looking and capturing requirements, we need to have different language and different terminology and different visions for each of those levels. But we mustn't negate any of them. Yeah, we can't just have a nice little cloud diagram and say that's the system. But at the same time, we mustn't just have the really detailed view, because that won't give the intent, that won't explain the why to the people. So it's key, like with any system and any embedded system, we must have traceability. So traceability is the core to all of our requirements. And ultimately, that traceability goes down into our design and into our construction. That ultimately, we want to have traceability down to the code level, say, where is this code? What goals is it satisfying? Back up this end means hierarchy within that. Also, the higher the abstraction, the less precise we need to be. We can afford these almost marketing type views, you know, the icon type views of the cloud and the connection, because that's right for that level of abstraction. It's enough to explain the concepts and the intent to the domain experts, etc. But as we get to the black box, before we move into the software design and the software specification, we must have precision. We must have a degree of detail at the system level, so that we have enough knowledge to go forward in that. Now again, if you're software only, that's not necessarily a requirement, and that's where the user story model can work, because you've got that degree of flexibility. But when we're dealing with systems, we can't escape bill of materials. We can't escape the fact that there is hardware, there is mechanical, there is systems, as well as the software within that. So what can we do in terms of modeling? Well, at the black box level, you'd say you could argue that's fairly well served. We do have accepted techniques, you know, whether you like them or not. UML again has been around for, you know, since the mid-90s. There is the thing called SysML. SysML is an extended subset of UML, very much aimed at the system modeling. So if anything, SysML is probably the appropriate abstraction level for the black box behavior, because it does have the concept of use cases in it, and that can be used with a degree of more formality to it if you follow certain guidelines and rules to have a systematic approach. But it also has the other core views we must address. We must address things like the dynamic view, the modal part, the state, and that's where things like stateful behavior and state machines come in. We must capture the detail of the interaction. This is where you have things like message sequence diagrams at the system level, at the boundary levels. There is a certain amount of structure to the system we must address. So there will be entities within the problem domain that have relationships we want to capture. So that, in a sense, the good old entity relationship diagram, if anybody remembers those, still plays a very important part in the requirements definition. And that's where people confuse those with classical items. They're completely separate concepts. And finally, our functional view, and that's almost the business process flow of how we work through different use cases, different scenarios. Those things need tying together. And SysML can do those. It has that capability to help us build that engineering view at the system level. But it's quite detailed. And it's not a good model to then take to, say, possibly a domain expert. It's got too much detail in that. What else do we have? Oops, sorry. Oh, sorry, I've gone backwards. Sorry, apologies about that. There are some of them out there. There is this one called AADL, I don't know whether you're familiar, called the Architecture Analysis and Design Language. It's an SAE standard within that model. Some people favour that. I think a lot of good stuff in AADL. The real problem with AADL is the lack of tool support in that, and instead it doesn't fit. So, but as an alternative to UML, it does sit alongside. So it is a true alternative to UML, and there are a number of companies really favour it, and I think there is a lot of value in AADL. Like I say, the real problem is a lack of tool support. The only one I'm aware of is an Eclipse-based tool within that. But again, if you're not familiar with it, you're not using UML, it's something worth looking at. But it's still really black box within that. In terms of the purpose level and sitting above the black box, the one I've got a lot of time for, and I'm a big fan of, and I came through it through the COVID's book. It's actually by a concept called problem frames by Michael Jackson. He always say not that Michael Jackson, that Michael Jackson. And what it does is fit very well. It's about domain analysis. So it has a number of patterns, really, in a sense, of trying to look at not just what we're building, but who else is involved. And where this can be really good is where you've got business processes that are outside the obvious part. So it's much better at capturing the human models as part of the system, or systems that are influenced in our problem domain, but we have no direct connection to. So let's say, so problem domains there's a lot of value in those, but and they've got precision, but they're not detailed as such. And then at the moment, like I say, and I'm still working through at the moment, is Levison's latest book. She's got this concept called her stamp framework, and this is around these models. And this is about this intent specification. So there's aspects of that again make you think about this requirements abstraction, this requirements model. And she has her own particular language. She's done a lot of work with people like the Federation Aviation Authority and NASA to look at the requirement. And where it's very good at is looking at things like you have requirements like no single point of failure. How do you fit those into user storage use cases? They don't. So we have to deal with those, and that fits in with problem frames as well to an extent. So there are others, but they all act as I'm not aware of any tools for problem frames. I mean, they're very simple to draw. You can sort of knock them up in PowerPoint or any graphical programming language, graphical tool, sorry. But that, of course, lacks an underlying model and the traceability and configuration of it as well. And the same goes for Levison stuff. There isn't really industry support for them. So in summary, going back to that original quote from Mike Cohen, so document a system requirements this level, is tedious, error prone, etc., and boring to read. Again, as I said at the outset, I don't disagree with it. I don't think, if you'd like requirements, it's not something I enjoy, but it's a necessity of life. It said, it would be lovely, I will read all this stuff about the Agile teams and working from the Kanban boards and not having requirements and having this dynamic fluid world thing, God, that sounds really nice, not to have a requirements document. But I just don't know how that works. You know, on the type of systems, you know, the embedded systems I've been involved in and I'm still involved with through customers, because so much of the time we're driven by standards. We have no choice. If we're in medical, if we're in safety, if we're in security. So the diagram on the right comes from the automotive standard called ISO 26262, which clearly has, you can see, so the V model, again, the V model is not about workflow, the V model is about traceability, but from a safety perspective, we have to demonstrate these things. Even though we might not want it, we have to have a requirements document, we have to have traceability. And anybody building a robust system where there is, you know, whether it's your company brand, but, you know, any embedded system, reliability's always been, you know, robustness and reliability is central to that. And as much as we know our requirements can never be 100% complete, there is a certain amount we must do from a system perspective before we embark on the software design, you know, and get into. And if we want to use Agile and Scrum and Kanban in the software design, you know, fine. But we cannot ignore those aspects at the system level within it. So Levison's, going back to Levison, you know, the way I've always approached to try and help when working with people and trying to get them to build better requirements document, I sort of use this high level model. I've always used this hierarchical model. And the way to think of it, it's what's called a goal-driven hierarchy. Everything is about the benefit, the why associated. But so even the what and the how are still have a why associated with them. And what you're trying to describe in the highest level is, you know, a year in the life of the product. What's the big thing? What fundamentally is it doing? And if you can't tell me that, then you probably don't understand what you're trying to do. The principles are more about the everyday, so, you know, things like installation, you know, that's sort of capturing that higher level, what goes on. So there's a degree of business process in that principles. It's very much seeing where our system fits into the business process, especially the business process of our client. And we must understand how they're using our system within it. And then the black box is much more, you know, a minute, a second in the life of. That's our engineering, the function feature things down at that detail. So how can we use what we've got? Well, certainly user stories, the upside of user stories, the informality, I found do actually work very well at those higher layers, if they're done correctly. Now, one thing I've seen straight away is people not, so that as a user, I want to go so that the benefit, and it's that so that the benefit is critical to the user story view of the world. So they work very well with marketing, they very well work with clients because of that informality, but you've got to have the benefit. And I see Agile teams not putting the benefit in there, and then they're not really doing user stories. Actually, they end up doing what we call functional stories within that. But they don't have that precision, that detail to then allow me to go forward and build a embedded software system, certainly in my view. And that's where I think use cases help formalize, pseudo-formalize the user stories. So it's not one or the other, it's both. Yeah, there is a direct correlation from user stories to use cases, because the way we've always taught use cases really are about user stories. We've always used a goal centric, which comes from Coburn. So from our perspective, there's a direct correlation that a good user story becomes a good use case in that model. So we can't. So at the high level, we've got to use this understand our domains. So there's an amount of work, an informal model we need to generate to clarify our domains, and that domain, there's a way of breaking that top level problem domain down into the sub problem domains, etc. That can be captured in a pseudo formal way through things like problem frames. So again, there is a direct traceability and correlation between the high level view, that problem domain solution domain, with Jackson's problem frames, because it really is the domain model within that. So we can take things from there. And the requirements part of the problem frame maps onto the user stories. So the little ellipse you have on the right called requirement, that really comes from a user story. So again, we can build this framework of traceability within that. At the lower levels, again, I'd say SysML is probably the best notation from a requirements definition, perspective down at that particular layer. And we can use sort of UML if we want to. You can sort of, the danger of UML, of course, it drives us down to software view too early. We're thinking about classes probably too early, where SysML has, it has a block structure rather than a class structure. So actually, I think a better notation for that system level black box. But even that doesn't capture everything. We still need to make sure we've got this traceability from the problem domain information, temperature, for example, to the software domain value. So there must be within our documents that traceability between those two domains as well. And every time we cross those boundaries from the problem domain to the solution domain, we cross two boundaries in a system world, the system boundary and the software boundary, and we must have traceability. So to leave you with a bit of recommended reading, Levison's book, like I said, I'm actually not finished it yet, but everything I've read so far is great. She's got the intent specification in there. But if you're into engineering, you're into safety, it's got to be a go-to book, along with her book on Safeware. I mentioned Kovitz a couple of times. It's probably out of print because I think it's about 20 years old, but it's still my go-to book. And that has problem frames in it. It has that domain diagram in it. It just changed my whole way of approaching requirements from that section. And finally, I'd like to point you at our blog. Glenn did a fantastic job of something called the Baker's Dozen of use cases. This very much captures our systematic use of use cases, which basically links into things like user stories. So just to finish off, like I say, where do we fit in? Well, this all comes from some of our training offering and our consultancy offering around things like SysML and UML, and also our work around Agile as well.